Okay, so the way I currently interface with the servo driver is through this USB to RS485. So as you can see, currently the spindle is turning at 300 to 299 RPM. So I wrote a little program that can actually force the registers for me, and I can find specific values that I'm looking for. So this is currently the servo driver. So if you look there, that is the actual speed. There's a speed instruction, and then I've got a whole list of addresses. So for instance, 2531 is the temperature one. So that's how I am currently interfacing with the servo spindle. Okay, so here I can use another program to basically send instructions. So currently the speed is 300, so let's make it minus 300. Let's just send the instruction. So now it's turning the opposite way, and if I want to reverse direction, so if I want to read multiple inputs, we can go here to the address we want, 28, and there's all the registers that I will be using in LinuxCNC. So that is using this dongle. Okay, so the next step I've taken is I've removed the USB dongle, and then I've connected the computer to I think it's a FT232, which is basically a serial. Then I've connected it to TTY modbus, and then the cable for the servo drive. So it's connected to the scope currently. So with this I can actually send commands using the USB to serial to RS485. So as you can see, I just sent the instruction. The motor did respond. Let's do a minus 400 RPM, and then we can see on the oscilloscope when I send the instruction. My little wire here is a bit loose here. I just need to hold it like that. Let's try to send the instruction again. So as you can see, instruction was sent. Let's see if we can increase the timing here. Let's send the instruction again. So yeah, it goes through to the servo motor currently. So the next step is to connect the TTY modbus onto the Mesa card. So let's quickly see. Okay, so we've connected the Mesa card to the Max 485, exactly the same circuit that I used on the previous run. So we have RX, ground, TX enable, TX, but that TX is the NAND of. So we connected this to our modbus. See, there's a little ground wire loose there. Let's quickly connect that. Okay, as you can see, there's no signals. So let's quickly switch on. Just make sure all the wires are in correctly. Okay, let's switch it on. Here we go, we switched on. You can already see there's a type of a signal. Let's quickly go into our LinuxCNC, execute it in terminal. execute it again. Okay, so there we can see there's a timeout. You can see there is data trying to be sent. So I have set parity to 0 and then changed it on the server drive. Then I went to 1, ran through all the options on the server drive, and then 2 again. So it can't connect. Throws a timeout. I can try and set the speed quickly. It's currently running on 400 RPM. So let's just see if we can maybe change it to 50, which I doubt it will do. So yeah, I don't know if it's maybe because of the Raspberry Pi, but I've tried everything that I could think of. I've built different circuits. I've actually used a standalone IC as well. You can see there's one. I've got another spare one lying around here somewhere. I even built a little board for that as well, and it just doesn't want to connect there. So yeah, I don't know if it's got something to do with the Raspberry Pi, but yeah, I doubt that. So it looks like the memory card is sending data. Either the server drive just doesn't understand it, or there's a mistiming, but there's no feedback from the server drive on the line that I can see. So yeah, that's a little update. Thank you.